Welcome to the Cloud Native Podcast, where we talk about all things cloud native. In this week's episode, we ask, what is cloud native anyway? All right, welcome everyone to the Cloud Native Podcast. Thanks for listening in. My name's Matt Farina. I work at Hewlett-Packard Enterprise as an engineer, and with me today is Matt Butcher, another person with a wonderful, great first name, Matt, and he works over at Deis. Go ahead and introduce yourself.
Yeah, I'm Matt Butcher. I'm glad to be here, and we're looking forward to having a chance to just kind of talk about what we think is probably the most important and interesting movement in technology right now.
Yeah, that's cloud native computing. You know, it's kind of a nebulous term, and folks talk about it in a lot of different ways. And so today, hopefully, if you're listening in, you'll get an idea of what that means compared to, what is cloud and just all the other technology trends that get buzzwordized. So the format of the show, since this is the first episode and you have no idea, is we're going to start by talking about something that's maybe news and noteworthy, and then we'll get into the main topic. And so, Matt, did you want to kick it off with the noteworthy thing for the day?
Yeah, sure. What I'm excited about today is this new technology that's on its way through the Kubernetes incubator called Kcompose. And this is a tool that I think is sort of an example of the kinds of tools I think we're going to see a lot for the next few years. Kcompose, spelled Kompose, is a tool for translating between Docker's compose file format and a more Kubernetes native format. And that particular group is on their way through the Kubernetes incubator, which means it's a new technology that's growing very rapidly with the hopes of becoming part of the Kubernetes organization. But what I like about it and what's fascinating me about it right now is the way that it's a tool designed to move definitions from one cloud native format to another. And I'm interested in watching that tool and many others to see sort of how all of these technologies and formats fall out in the future. So you can take a look at that at github.com/kubernetes-incubator/Kompose. That's Kcompose.
So with Kcompose, right? So we've got these different formats. You've got Docker, Kubernetes, there's Mesos, AWS has a proprietary cloud container service. And well, they do a lot of really, really sometimes similar things. The API, that format is different between each of them, right? You may have YAML files, but what you put in them is different. And so here, this allows you to take what Docker's compose files and then run them inside of Kubernetes.
That's right.
All right. I love that ability to have that transition. So let's jump to the main topic. What is cloud anyway? And when I started to think about this, what I started to ask the question of is, well, what is cloud, right? Is it a buzzword? Is it a substantial difference? Is it anything new? I know there's some of us out there who will get offered this solution, especially in the enterprise space, where they say, here is cloud, and they'll hand you something, and they say, fill out a ticket, and in 24 hours, you can get a VM. This is cloud. And I'm thinking to myself, back in like 2002, I was using a VPS provider that nobody ever dubbed cloud, and I could do something maybe faster than that. Maybe I could get it in a couple hours or less. And here, does that fit the definition of cloud? Or is it, as a friend of mine, Eric, who I work with, likes to say, he says, there's crab, and then there is crab with a K. It's not real crab. It's imitation. It doesn't quite taste the same. It's crab with a K. And how often are we fed cloud with a K? That's not the real thing. Not to be confused with Kcompose, but
I was just going to say, you're undermining my new and noteworthy of the day.
And that was not intentional, but Eric Gustafson, who I work with, I mean, he says, is it, so maybe the question is, what is actually cloud computing? And then how does it relate to cloud native? And so cloud computing, I grabbed a couple of things. There's the Wikipedia's dictionary, which is what the Dictionary, something like that. They defined it as, and I wrote it down, computing services provided over the internet whereby shared resources, software, and information are provided to computers and other services on demand. and I pulled out two particular bits. One is on demand. I think of songs. I want what I want, and I want it now. That's the on demand thing. And then there is the whole idea of a shared service. It's not some kind of dedicated thing. You've got shared infrastructure or shared stuff. And a lot of times we think of infrastructure and you get a piece of it. And if you're not using it, you can give it back or you can get more. And it's shared and passed around. And it's that kind of concept for cloud. What do you think about that?
I'm curious how you would, given that definition, the word that stands out, or the phrase that stands out to me there is over the internet, because that seems to sort of shut down the possibility of private cloud. I like that you keyed into the on-demand aspect. I think that if we're going to talk about private cloud, we would have to sort of get rid of the idea that it must be available to people over the internet. What do you think about that?
That's a really interesting point because one of the topics I do want to touch on in the future is private cloud because we hear the terms private cloud, hybrid cloud, all of these things. And you're right when you talk about over the internet. But I start to wonder, right, how much of we'll call it on-premise or private clouds, what's the difference between on-premise and private cloud? Is it accessible over the internet if it's not in an AWS, Azure, Google data center, but it's in your own company's data center, but you can access it over the internet? How much of a difference is that?
Yeah, no, I'm really not sure. I think over the internet might be one of those red herrings that might send us down the wrong path. I think some of these other things may be more crucial to what it means by cloud. And I think in particular, one thing that stands out to me as being definitive of cloud compared to bare metal, which wasn't even a term until we had cloud, right?
Yeah.
Is this idea that we introduced an abstraction layer between the OS and its drivers, right, and the actual implementation of it underneath, to the point where you can run the same operating system installation on multiple different hardware configurations and never really know that you're running it on any of those.
Yeah, yeah. And what we really end up with is maybe an on-demand API to manage infrastructure, compute, storage, and network at its core, and that's infrastructure as a service. And then software as a service is kind of, built on top of that. And then there's platform as a service too. And we end up with a whole bunch of services that we can consume and kind of do what we want with, right? You can attach and reconfigure. You can innovate on storage and networking. Maybe somebody's got faster storage they charge more for. Or they've got cheap storage that's cheap, but it's long term and it's really slow. And you can innovate in all these ways, but you've got an API on it, which means it's programmable.
Yeah, and I think that API essentially gives you that abstraction layer that I was trying to get out there, that there is a certain abstraction layer from the hardware. You can be more ignorant of what the hardware is. And also, there's an expectation that you won't have access to the hardware in quite the direct way that you would if you were, say, working on a native operating system running on bare metal.
And I think this is where it kind of crosses that chasm into, well, what is cloud native? Because we've had cloud computing now, this API on the resources and other stuff for just over a decade now. And what we saw is the way that you can build things is different when you do it this way. It's not I stand up a machine and it's going to be long running and I've got to load up everything on it. I can start to do some really interesting and different stuff. And how do you think that's affected how we've done applications?
Yeah, I mean, if we're transitioning from merely talking about cloud to talking about cloud native, then yeah, that's where we can really start to talk about how the introduction of cloud as sort of a base level infrastructure tool has matured really and altered the way that we then look at how we can develop applications, to the point where when I think about cloud native, I really think about the next level after merely cloud, the level where we start saying, how do we optimally build applications if we know that our target is going to be the cloud, right? I mean, when we look at the rise of AWS and OpenStack and Azure, I feel like what we saw in the first generation of applications that were run on the cloud was largely just the same old tools, the same old processes, the same old procedures that we had been using on bare metal, just simply migrated into the cloud. But now I think we're seeing a second or maybe third generation of applications that are being built with the assumption that native, on bare metal on a multi-tenant operating system is not really the destination for this app ever. Instead, we're starting to build applications where we assume that their environment will be a virtualized server, or really more these days, a container.
So, what it sounds like to sum it up is so we got these cloud computing, we got these APIs, and we kind of stumbled around with the way we had been doing things, but still using these APIs and figuring out, you know what can we do with that? If this is a platform, if this is something different, how can we take advantage of the APIs to build applications in a new way? And we kind of wandered around in the dark, feeling it out, trying to figure out how do we do this? And after feeling around for a while, we've kind of come to the light and say, and that's kind of what cloud native is, isn't it? It's
Yeah,
figuring out how to use these services and building apps in a different way that really leverages their power.
yeah. And I think, stumbling around is a good way to describe the way we did it for a while. Take a quick, mental survey of some of those cloud technologies that we saw, some of which were a flash in the pan and others which really stuck, right? In particular, the ones that really stand out to me are technologies that started really with Rails and made its way into Heroku, for example, or Cloud Foundry. These kinds of environments that were shaped by the 12-factor methodology, and that I think really started to give us a hint toward a different way of developing applications. Where we didn't take it for granted that we had a lot of storage readily available, but we did take it for granted that things like load balancing would just happen for us without us having to do any real work. And I feel like those were some of the baby steps toward rethinking the way we developed applications from, gigantic Java applications running on dedicated, 4U servers to this really sort of slimmed down special purpose application.
So when we get to this special purpose slimmed down application, a lot of times we talk about microservices. In fact, if you go to the CNCF, the Cloud Native Computing Foundation, which oversees a number of things such as Kubernetes, FluentD, Open Tracing, Prometheus, a number of open source projects in this cloud native space. They used to have up on their website, it may be up there, but I'm not exactly sure where, a definition of cloud native. And it touches on some of the elements that you've brought up already. And it was container packaged, dynamically managed, and microservices oriented. What do you think about the different parts of this? Do you actually have to have them to be cloud native? Are they important? How do they play in?
Yeah, we should unpack each of those terms real quick, shouldn't we?
Yeah.
I'll take container. What we saw with a lot of the first wave ones was a tendency, like AWS, has been a tendency toward a full virtual machine layer, and the container managed model really gained popularity under Docker, right? Where you could define, hey, I want a file system that looks like this. I want to load my particular binary or my particular application into it, and I want to execute it in that sort of isolated, containerized environment. Now, this I think you can contrast really well with the way we used to do development in a typical Unix or Windows system, right? Where we might have dozens of services running next to each other. We might have a database, we might have a web server, we might have the application server, all of these things sharing the same operating system. And more importantly, sharing the same file system and sharing the same set of libraries, right? And containerization, I think, has sort of changed the way that we do things. And we have stopped viewing the target package as being just the application. But now we sort of have expanded our notion of what the package is that closes over our application. And we talk about it as the whole file system layout. And that really is what the container environment gives us, is sort of a packaged up file system that happens to have our target application running in it. And that pushes the focus from the particular binary to the binary plus its very specifically crafted environment. How about dynamically managed? How do you define that one?
So the way I view this really came out of working with Heroku and our time doing Cloud Foundry stuff. So when I think about it, dynamically managed is, it's being managed by a system on the fly. And so I started off, I've done stuff in things like Chef and Puppet and Ansible, where you grab some machines, you basically grab some of these resources and you orchestrate them on the fly. And you might have some APIs to look at management and change things up and scale them. But really, if everybody does this themselves, then we're all doing it, poorly because we're doing it for my set of resources. Somebody else is doing it for their set of resources. A third person is doing it for their set of resources. And it's not optimized for the underlying system and all the workloads. Let's flip that around. Just put an API on the front of it where you hand your workload to the API that describes it and has that container packaged, and let it figure out the best way to run it, to schedule the workload with storage and networking, all of these things, and go ahead and run it. And then over time, change it as needed. You need to scale up, scale down. You've got servers that are overloaded. You need to move a workload. The system can know how to do it better than a bunch of individuals. And so let the system dynamically manage the life of the application over time for everybody. And I think that's where we get into dynamically managed. You see a little bit of what Google called it, the data center as a computer. And so they viewed it that way. In fact, they've got some publications on it to look at just viewing it differently. Instead of a bunch of resources I manage, it's one big computer or one small one if you're just developing locally, and just let the computer run itself and schedule itself.
Yeah, I can remember back when we needed to know the server names for every server that ran our particular application. And I can think, when at about.com, we had 17 designated servers, each of which we knew which one was running, the principal primary servers and which ones were running the failovers, so that if one of the primaries failed, all of that seems to have sort of faded into the background with this idea of a dynamically managed provision scheduler, right? Where I may never know which particular physical machine is running my particular server at any given time, right?
Right. So,
and
okay.
that I think is one of the things that cloud native captures really elegantly. What about microservices? How would you explain a microservice in a nutshell?
Microservices are maybe one of the more controversial because they're an architectural style more than anything, about having a service that is an individual unit and then having a number of those individual units communicate with each other over APIs. I mean, you can do this kind of organization with packages inside of a single application. And it's just a matter of taking out those smaller components, running them as their own applications that you can now schedule, scale, and iterate on independently. And so that's the way I look at it. It's just taking that small, single-purpose chunk of stuff, and instead of making it a part of a larger application, make it its own application.
And Matt, you know that I have a little bit of a problem with the inclusion of microservices in the CNCF definition, because we just described container packaged applications and we just described dynamically managed ones, right? These are sort of descriptive things. And then when you get to microservices, it feels like you sort of get into this prescriptive mode where you start telling people, well, you really need to design your application, and then you use some fairly generic terms like to be small and single purpose and have an API front end, and you group them all together. But small, of course, is in the eye of the beholder, I think. And, groups of applications running with APIs in the front end, man, that doesn't seem like anything that has been new since maybe the mid 80s. So for me, I feel like microservices is not an essential component of the definition of cloud native. I feel like focusing on the container and focusing on the dynamically managed aspects are true, but I think the whole idea of a microservice is just a little bit too squishy to be all that meaningful. And if you were to prescribe something really for how you ought to develop applications, I feel like you'd want to really focus more on maybe how they tracked state, how they used shared libraries, maybe how they bootstrap themselves into the environment. But focusing on the size of the binary and the API, those seem to be sort of like out in left field compared to the rest of what we've been talking about cloud native wise.
So I'm going to push back a little. So think about this, right? With cloud native, you can scale your applications horizontally, and you can have one instance to 100 instances to 1,000 instances, depending on what you need. And if you've got one piece of functionality rather than a bunch of different ones glued together, doesn't that help you scale better in a cloud native manner by having these smaller chunks that you can individually scale?
I suppose I could see why you might say because cloud native seems to handle horizontal scaling better than vertical scaling. That is, it seems that cloud native can spin up more of the same thing better than it can spin up one thing and then scale up its memory and processor consumption as needed. I could see why, given that particular constraint, you might want to say, well, you ought to focus on small as a goal. And I understand that. I just feel like that's not necessarily an essential quality of cloud native. I feel like the microservices thing was a trendy buzzword that sort of captured the ideals of maybe some places like Google that have certainly done an excellent job in building what they would call microservices. Although I would still submit that many of the things they call micro are the size that many of us would consider rather monolithic. But that said, I can understand why that made it into the definition. I just think it's not necessary to it. I think that if cloud native is to work the way it is to work, then that it needs to work in order to facilitate the kinds of workloads we're going to be dealing with, then microservice is not an essential property of it. I think that databases are not microservices, but we're going to have to run them this way. Right? Mail servers are not really microservices, but we're going to have to run them this way. And so if we're already sort of trying to roll out things that we know we need, by definition from cloud native, we're going to keep ourselves employed for a really long time rewriting stuff that already exists and that we would otherwise be able to use.
It's interesting that you bring this up because, microservices also have some major pitfalls. For example, if you have all these network communications between all these services and you're creating network connections, negotiating them, transferring stuff, dealing with TCP slow start, it can actually take a pretty big performance hit compared to just passing around some variables inside of an application. In fact, the more I think about it, I think this microservices stuff is something we should probably touch on in the future sometime.
I think so. I think we should. I think a good point of contrast for it might be to compare it to the early Unix philosophy that tools should be single purpose, and see how that particular philosophy has played out over the history of Unix and compare that with microservices. We should definitely talk about this again in the future.
All right. One of the things you were just touching on was databases. And databases are interesting because, for a little context here, there's this thing called 12-factor apps. Go to 12factor.net. And if you go there, you'll read a manifesto on building applications primarily targeted at Heroku. So you'll see it really targeted at their services. And so this plays well for Cloud Foundry, which is essentially a Heroku-like clone that you can run on premise or wherever. And there's this idea of 12-factor apps, which discusses a lot of the characteristics that I would say are cloud native applications. Some things I would put a little bit of a twist on, like the way they do logging and things of that nature. But one of the qualities is they talk about them being stateless when they're 12-factor. And when Heroku came out, it was like, okay, there's these stateless applications, usually web apps, and this is how we're going to run them in our services. And then you're going to have this stateful database you'll access through an API or through some service. And we're just going to kind of push this into the background and pretend it's not there. But times have changed. And state is now in the conversation. It's part of the equation. Can you talk a little bit about that and the change?
Oh, yeah, sure. I think that you have sort of there are two ways to ground this conversation. Heroku is definitely one in the 12-factor app is definitely one. And the other thing to keep in mind is the way that AWS and Azure and Google internally, the way Google has evolved. That too is a good example here. So let's talk about Google to start with, for example. Google has famously, for over a decade, had a proprietary data storage system internally, a big table where they would store all their application data. And they ran applications that would then connect back to Big Store and use that for its storage. AWS did the same thing with DynamoDB, with database as a service offerings, with S3, and of course, Azure has done the same. Now, what's interesting about all of these things is that the development philosophy that Heroku, AWS, Google, Azure have all sort of promulgated has been this idea that you build your application, and your application is largely either stateless or reliant upon some other service to preserve state for it, right? But if we're going to move all of our applications into this environment, then they can't all be stateless because something somewhere along the line has got to provide the state storage, right? We want to run a cloud native database. And we want our cloud native database to keep its data when it recycles, or when we spin up another copy, we want it to be able to access the same data. So it can't all be in-memory storage. And I think that may have been one of the biggest learning challenges for those of us who have been on sort of the cutting edge of the cloud native world, because initially we really wanted to believe, I think, that the 12-factor stateless story, that the Google stateless story, that the AWS stateless story was the story, and that we could do it that way. But very rapidly, we started to resent the fact that we could no longer write applications that took advantage of 20, 30 years worth of storage technology now, right? And so we've sort of, in a rather painful way, begun the process of relearning when stateless is virtuous and when stateful is virtuous, and also how to implement stateful in systems like Kubernetes.
Which is turning out to be an incredibly complicated task to do well. So I want to back up a minute, because I think you covered state pretty well here. But one of the things that we touched on just a couple of minutes ago, with the whole evolution of things, VMs and then containers, and what we never talked much about was, can you do cloud native with VMs? And so the CNCF definition said, it's container packaged, right? Which fits perfect with the definition of we're doing Kubernetes.
Right.
But if you start to back up for a minute and you think, as we figured out these services, we did things a little bit differently over time, but it comes into how we came into cloud native. And yet companies like Netflix with VMs were doing a lot of the kinds of things we talk about now with containers. So can you do VMs and cloud native?
See, that is an excellent question. When we were talking about containers, when we introduced it, the primary way we were talking about it is as a way of packaging up your application, right? And we talked about it as packaging up a file system. Well, from the developer's point of view, packaging up the file system and running it in the same kernel as other packages is not really very much different than packaging up the file system plus the kernel and running it in another virtual machine, right? And that, by the way, is really where, at least it's the way I see things, is with something like Docker, you're packaging up a particular representation of the file system, but you can run many of these on the same operating system kernel. With a virtual machine, you package up both the kernel and the operating system, and any other supporting libraries you need depending on the architecture, and you run those together, on yet another host machine. So to me, it seems like that particular part of the definition too may be a little bit suspect, right? It doesn't seem to me like whether or not you include the kernel ought to be the sole property to distinguish whether or not something is cloud native. What do you think about that? Do you think the kernel is in some way some blessed object that we ought to use to divide between cloud native and not cloud native?
I don't because, as we talked about early on, cloud native is taking these services and using them to build applications as optimally as we can. It's a new paradigm for building applications instead of figuring out something that will run on, say, a kernel on a system as the platform. Now it's a bunch of APIs to services as the platform. And so I think VMs entirely make sense. In fact, I think they were the area that broke ground on what cloud native is. But I think it's the reason we're getting hot on containers is it's the benefits that it brings. You see, we did some really amazing things with VMs, but their startup time isn't exactly what we wanted, nor their teardown time. And moving around, I mean, how big were those images to move around and to start up? They were
Oh,
pretty
gigs
big.
upon gigs,
Gigs
yeah.
upon gigs. And so with containers, what we kind of got was a refinement on them that let us use less storage space, less network traffic, and we could really grab a hold of some of those lower level resources with fewer VMs, right? Fewer kernels running out there, and yet still get a lot of the same things. So when I look at containers and what we do with them, I think it allows us to be smaller, faster, and that kind of thing, rather than it being some new amazing thing on top of VMs that now defines cloud native. What do you think about that?
Yeah, I think you hit on exactly the right level of abstraction there. So we were talking initially about the cloud as being a new sort of infrastructure layer, right? And then when we started talking about what cloud native is, we were talking about the way that developers develop applications in a way that thinks about the cloud as the primary platform, not as some newfangled thing we'd have to port to. So we immediately narrowed the focus down to talking about the developers' conventions or the DevOps conventions for building these particular kinds of applications. And what you just said is dead on right. The developer wouldn't really have to build the application differently for a virtual machine versus a container. And so if that's the case, then that abstraction really wouldn't, or that particular, the inclusion or exclusion of a kernel isn't really the right place to divide between cloud native and not cloud native. So I think you were right there. I think you hit the exact right thing by saying it is about the developer and the way the applications are built and executed, not about the way we choose to package the application in sort of that external view. But I also strongly agree that I think that the reason that virtual machines have been losing traction recently is for that very practical reason that we don't like waiting for stuff to start up and tear down. And they are, honestly, quite a bit more resource intensive. You need enough memory and enough processor power to run multiple kernels instead of sharing one kernel.
So talking about packaging things up and startup and performance and this cloud native not being constrained to containers or VMs. There's this thing out there called Lambda functions that AWS has, or Google and Azure both now have their own functions. And there's even Fission for Kubernetes. And it gets to this idea of now I'm not talking about an application that runs. And now I'm not even talking about a microservice sitting inside of a container. I'm talking about an individual function that just runs on an event like a web request to a URL or a cron job or, a timer or something like that, or an event from something else. Say something's been uploaded to storage and, we'll fire off this function. And we've kind of changed, the paradigm's starting to change again. How do you think that fits into the whole cloud native definition?
Ooh, well, I'm going to turn this right back on you right away and say, so how would you explain to someone the difference between this serverless stuff and the Lambda function stuff and the older Heroku / Cloud Foundry style application?
That's a good question because it's really similar. In one way, I guess the real difference is in one, I have a single function in JavaScript or Java or whatever language. And in the other, I actually have an application which is a collection of functions. And the difference is, am I talking about one function that schedules on an event? Right now, I don't have to worry about the router coming in. But if you're doing PHP or Python before, you didn't have to worry about some of that before either. You just had to hook into, I guess, when the request happened. I'm thinking off the top of my head here, as some of you can probably tell. But I think it's the difference between now I don't have to worry about the routing. That's done in the service. And now I've just got a function that does it for the event. Where before, Now I had a collection of functions and I had to figure out what routed where, but I could have those functions chained together in complex forms. And I don't know that the Lambda, the serverless, has quite figured that out yet, but I bet it's coming.
I think it's coming. But I agree with you there. And I think that once again, we're sort of talking about how we package these things, right? In the case of serverless, there's a sort of documented entry point, and all the packaging around it is designed to know where that entry point is and execute that particular entry point. In the older Heroku model, you would have a proc file that said, here's how you start up my application and you run it. With serverless, the documentation says, here's how you set up your function so we call it correctly. And I think you're right about that. I do tend to worry that that we have dressed up a framework, because I think that's what serverless is a framework. And we've dressed up a framework as if it were some new revolutionary new cloud layer, when really it's just a framework. And I think we'll be able to use that framework in much the same way that Rails made it much easier to develop applications, or Django or Cake or any of those web-oriented frameworks. I think that serverless is the kind of tool that's going to open up some opportunities to build very small, lightweight tool chain things, right? Again, I already mentioned this earlier. There's this Unix philosophy that you develop a command line tool to do one thing really well. And I think serverless has taken the approach that that they want to stick to doing one thing. But I'm not totally convinced that they bought into the second half of the Unix ideal, which is that you should do that one thing really well. I think they're really kind of emphasizing this very minimalist model where you do just one thing. And that may have some value, especially as we learn how to start building complex chains, pipelines of things based on the ability of one function to do one thing.
But think about this, right? So I could run containers in some VM somewhere, look at the cost per month, and I can run a VM, service, and even run it as HA. I got a few VMs to keep my HA-ness. But I've read about folks who've written things like API servers that can do get, post, just the different REST commands, store things in a database, serve up some static files, and basically be the back end for something like a mobile app. And using serverless, have been able to do it for things like $25 a month and less, because they're only getting billed for when that function is running, which isn't all the time. But if I package something up in an application and run it, I would be hard pressed to, get a production, 3 servers running for a month with persistent storage for that cost. Isn't part of not just doing it well, how we grade well, and maybe the cost that comes into that?
Yeah, now you're going to force me to backpedal, aren't you? That actually is a great example of what serverless gives to the providers. When we make purchases of, it used to be the case that when I bought a server, I bought a server that was spec'd out to peak load conditions plus some, right? And then with the cloud, that particular part of my job changed a little bit, because I knew that I could scale out horizontally for very cheaply. But the game for, say, the provider like Microsoft or Amazon or whomever, they still had to do the same thing, right? They had to say, all right, we need this many nodes that will be able to handle this kind of maximum capacity. And of course, any of you who've set up OpenStack know that that's the math that you have to do when you set up OpenStack for people. And I think it's kind of brilliant that Amazon came up with this way to say, wait, we've got extra capacity. What if we could figure out a way to get customers to use that extra capacity, but in a way that was so self-contained and so short-lived that we could use up some of the extra capacity without then having to redo the whole calculus of what can we handle during peak. And I kind of think that was the mentality that led towards serverless. And maybe that's the really brilliant part of serverless. And maybe I'm not giving it its due credit. It's a way to maximize the capacity maybe predict a little bit better, but without keeping a virtual machine running idle, consuming at least some percent of the CPU all the time. And again, I'm making some assumptions about how this is actually implemented, but I suspect that that might be what's really going on there.
That could be. And so, what I think, just to sum up all the stuff that we talked about, when it comes to cloud native, and I think each of us could give our own definition here, but I think when it comes to cloud native, what is cloud native? There's these services and this ecosystem of services that is growing and changing. And I mean, in just 10 years, we've gone from VMs to containers, and now we have serverless with Lambda functions or functions, or however you want to call them. And it's this changing microcosm of technologies and a new form of platform. And that's cloud. It's really changing, and it's API driven, and it's on demand. But cloud native is actually building applications designed for that environment rather than for, say, the computing environment from the 1990s or the early 2000s, or if I just have a computer sitting under my desk and I'm going to run an application on by itself. It's running applications built for this new paradigm. And I think that's when it comes to the show, it's how do you go about building applications for this paradigm to attempt to be successful? And how does it change? What can you leverage? And that kind of thing.
Yeah, so in the future, we're going to want to be talking about things like maybe unikernels or declarative syntax and declarative programming, how to manage the storage of these things, how to start thinking about things like dynamically linked libraries when there's nothing else to share the libraries. Because these are questions that years ago we might have considered sort of no-brainers, right? There was just a certain way you did things. But now, with the transition to thinking about cloud first and thinking about things as containerized, as ephemeral, that's a new word, as ephemeral, as, short-lived processes scaling out horizontally. Many of the things we talked about today, these things change the way that we're going to be building apps for the future. And what excites, I think I can speak for both of us when I say, what excites us about this is that it really does open a lot of potential to build more complex systems that can accomplish more with fewer resources. And with the rise of big data, with the rise of machine learning, we're going to want to be able to leverage these things, leverage every piece of hardware we have to the maximal extent, but do it in a way that doesn't involve all of us being on call at 3 o'clock in the morning.
Exactly. I like that last part. How do we do this to not be on call and get woken up regularly at 3 o'clock in the morning? I value my sleep. In fact, I think that's one of the things we should probably talk about in the future. How do you get that sleep? By automation. All right. So I think that's it for today. Thanks, everyone, for tuning in and making it to the end. And we'll be back again at some point to talk more about cloud native. Thanks for coming.
Thank you.